Now, a small percentage of galaxies are so-called active galaxies. They emit enormous amount of energy in the form of radiation from a rather small region in their centers. AGN is an acronym for active galactic nucleus. So it's not that all galaxies belong to that group. For some reason, and we now have a pretty good idea what's causing that emit an enormous amount of energy from rather small volume compared to the size of the entire galaxy. So the first group, so-called Seyfert Galaxies, after Carl Seyfert, who discovered them in the 40s of the 20th century. Okay, and they are spiral galaxies, and the intensity of their radiation from the nucleus varies on the scale of minutes. Okay, so let's take a look at one such galaxy. Okay, so you can see that actually they emit light. There's other radiation as well, but they are visible, they are observable at visual wavelengths. And from the fact that their luminosity varies on the scale of few minutes, we can conclude safely that the size of the region that emits radiation, it cannot be bigger than few light minutes. Okay, so how big is light minute? Remember, or at least those of you who took astronomy 1P01, it takes about 8.3 minutes for light emitted by the sun to reach us here on Earth. That's one astronomical unit, right? So the size of the active region is on the order of astronomical unit, which is tiny compared to the size of the galaxy of 100 or a few hundred thousand light years. So the region from which they emit energy is very, very small compared to the size of the galaxy, right? So that's comparable to one astronomical unit and is much smaller than the diameter of the galaxy. Okay, and on Wednesday I'll explain how is it that we can deduce that from the fact that the intensity of radiation from Seyfert varies on the scale of few minutes, how we can conclude that the size of the active region cannot be bigger than a few light minutes.